Hey guys, it's Mr. Dugal, and today we're going to talk about how you can utilize lines on a graph to find slope and use that to find information helpful to us. So right now we have three different lines. We have line A, line B, and line C. And the first thing that I want to point out is what is called a lattice point or lattice points. By finding a lattice point, that's where it intersects both an x and a y coordinate at an obvious whole number, or the lattice points that help us the most. So, for example, this is a real easy lattice point where it intersects an x and a y axis is our easiest. But we can also visualize that right there we have another one. That'd be 1, 2. You could also see that where it crosses 3 at the y-axis, that's not going to be great because it falls kind of in between 1 and 2. Looks like it might be 1.5, but it also might be something different. So that's not as strong of a lattice point. So lattice points are where they cross x and y coordinates on the grid. And this is a definition and a concept that helps us moving forward. Because basically, if we can find two lattice points, that helps us to find the slope and will actually allow us to find the y-intercept and eventually the whole slope-intercept form. So our slope-intercept form is y equals mx plus b. And when we have this, we're going to start out finding slope. So we have m equals the change in y divided by the change in x. And we can notice that it is growing by 2 in terms of its height. So the top would be 2. Per every 1, it's growing in its x. So that would be 2 over 1. The slope would be 2. We can also tell that our y-intercept is 0 because on the y-axis, when x is 0, y is also 0. So that is our y-intercept. So when we plug this into our placeholder, remember y and x kind of act like placeholders when we do slope-intercept form. We have 2 to be the slope, and then it'd be plus 0 if we're using this formula. So we can just actually leave that off. So it'd be y equals 2x for line C. The reason line B is on this graph is because it shows us an example of a different slope, and we can just look at C and B and tell which slope is greater. So in this case, our x-axis is minutes, and our y-axis is pages. So this would be an example of someone reading a book and the amount of pages they can read in a minute. So something that we can infer from this table is that student C is a faster reader. And that is because the line C is steeper than the line B, which means it has a greater slope, which means that student C reads more pages per 1 minute, which would mean student C is a faster reader overall than student B. Student A, it's not as obvious. Student A looks similar to student C in terms of who is a faster reader, who has a stronger slope. So we're going to find two lattice points to help us. Our first one here would be 0, 6. That's our easiest. When we go to find our next obvious lattice point, and these are obviously rough sketches, so when we go to do this on a real graph, it should be a little more apparent than it is on this white space. But we can estimate that 210 would be another good lattice point. So we notice that for every 4 it's rising in terms of its height, it's rising 2 in terms of the horizontal growth. So we would say m equals 4 over 2, or again, our slope is 2. When we evaluate our y-intercept, we see that when x is 0, the y-intercept is 6, the y-coordinate is 6, so b is 6. So for A, our line is y equals 2x plus 6. When I go to evaluate line A compared to line C, it may look like at first that student A is the faster reader because student A's graph appears higher. But I want you to stop and think about what would it mean if their slopes are the same but the y-intercept is different. What this actually tells us is that student A and student C are equally as fast readers, that they read the exact same amount of pages per 1 minute. They both read 2 pages per 1 minute. However, student A started further ahead than student C, which is why the graph is higher up. And that's what the y-intercept represents, that before it even started, student A was already on page 6, whereas student C hadn't started the book yet. And as they kept reading, their rates were the same, so student A continues to stay ahead of student C. Slopes that are the same will be parallel to one another, so you'll notice that these two lines are parallel to one another, and that they are both steeper than student B. That's about it. Hopefully this information is helpful, and thanks so much for listening.